Okay, see. So here the word, no, simple harmonic motion, I have never discussed. Okay, so SHM stands for simple harmonic motion. And whatever I discussed actually yesterday, okay, that oscillatory motion, right, an object going back and forth about a particular point, okay, that particular point I told you we call it mean position. And if the object is really going, okay, the back and forth about this mean position, right, okay, it goes to A, it goes to B, then such motions are called oscillatory motions. And another way of saying that oscillatory motion, right, we can also call it simple harmonic motion, okay. But all oscillatory motions are not simple harmonic, okay, so you have to understand that also. That will come in the picture later. But basically I want to just say right now whatever we have done yesterday, that is we are going to use today, okay. So say the equation they have given is very simple. Yesterday, let me write yesterday's equation actually, okay. If you remember, how do you write, guys, displacement or position relation? Position time relation, no, at what time what is the position, okay. I've discussed yesterday. We have an amplitude in front, then we may have sine function, then we may have omega t, and I told you we may
Plus
also have
theta.
plus some angle phi. It may be present, it may not be present, it may be 0 also, but we have an angle called phi, okay. Let me just remind you, this is called position. Y is represents position at any time, and the time we are talking is small t, okay. Small t can take any time that you want. You want to talk about position after 5 seconds, small t can be 5 seconds. You want to talk about position after 10 seconds, small t can be 10 seconds. If you put t equal to 10 seconds in this formula, that means you are finding the position at 10 seconds, okay. Then this phi, if you remember, I've called it phase, and phase gives you an idea, right, okay, where do we start from, okay. The object can start from anywhere, no, that's what I told you. The object can start from the mean position, the object can start from the extreme position, or actually from any position, okay. So the phase is going to help us decide that. For the time being, just remember it is phase, okay. This A, I know you already know what is this. This is called amplitude. It represents how much extreme value of y can take place, right, okay. So on this side I'm taking it to be plus A, on this side I'm taking it to be minus A, right, okay. So you can go extreme minus A meters or centimeters on the left, and on the right you can go extreme plus or minus A, okay. You can imagine this example by taking swing, right, I told you you can go back and forth, so you go maximum to the right, maximum to the left, okay. The maximum amount of displacement to the right or the left, okay, we call it amplitude, okay. And omega, of course, okay, very important property. Omega, I told you, represents your angular frequency, which is 2 pi f, okay. It has a unit of radians per second, and your frequency, of course, I told you it is 1 over the time period, okay. And frequency, of course, has a unit of hertz. This is the information I gave you yesterday actually, okay. And I've drawn, of course, all those graphs and all. But yeah, I think we are ready to start this topic. Say, so here the question, no, says the position time relation is given. Say this is position time relation, okay. Let me write it down. Solution, of course, don't check here, no need to check there, okay. Say oops. So we have y equals 0.24, then we have sine, and then we have this number called 400 inside bracket, okay. 400 and small t, and then we have plus 0.5, okay. In SI units, SI units means, of course, y is position, so it is measured in meters, okay. So that is what they mean by in SI units, okay. Then the question is find the amplitude, okay. So you can directly write, compare and tell me, right, these two equations, check this and this, compare this, and of course compare this, right. Can you tell me, guys, what is the amplitude in our case? How much is A equals to?
0.24.
Yes,
0.24.
I cannot hear you. I cannot hear anyone.
0.24.
Oops, I did not plug in the
0.24.
1 second, huh? Hello, can you hear me?
So 0.24.
0.24, okay, correct, but he is not complete. Can I just say 0.24? I have to mention the units also.
Units.
So what is the unit?
Meters.
Meters. Amplitude is going to have meters, okay, units. Y also has units of meters. Amplitude also has a unit of meters, okay. Then tell me, what is the next answer? Frequency. How do you calculate frequency?
1 by t.
1 by t, but do I know t or we don't know t here? We don't know t, right? But we know something, right? What is this 400, guys? Tell me. This 400 must be equal to what?
So omega.
Omega, right? Okay.
Omega.
Okay. 400 is not omega t, okay? It is just omega represents frequency, okay. So I'm going angular frequency. Omega equals to how much? 400, okay. So they did not say anything. That means what is the unit, guys? Radians per second, okay. So now you tell me, if I have omega, I can write 2 pi F equals to how much? 400, and from here I can write F is equal to how much? 400 divided by
2 pi.
2 pi. Okay, so you can just keep it like that, or at least one step we can simplify. I can write 200 by what? Pi, and of course this answer will be coming in hertz. Okay, it's because it's the frequency. So we got the second answer also. Okay, the time period is very simple. How do you calculate time period? 1 over
Sir,
1
inverse
over
of frequency.
So inverse of frequency means it's going to be pi by what? Pi by
Pi by
200. Okay, and pi don't write. Okay, you are not allowed to write comment. Don't use pi equal to 360 degree. No, you are not allowed to do that. Value of pi is what? 22 by 7. Okay, so that is what you are going to use if you want to simplify further. Okay, you have calculator, you can do it. Okay, but of course this answer is going to come in seconds. So I think this problem was very simple, right? So please expect. Okay, MBOS, I'm sure. Okay, I'm sure MBOS also, CBSE also. Okay, I'm sure this kind of question they can ask. Okay, so CBSE, MBOS, very basic one. Okay, so they can ask you. Okay, if this question doesn't come, okay, you cut my nose. Okay, so see, then okay, I'm not going to go into other things right now because yeah, similar type I'll not do anymore right now. Okay, just be prepared. This can come. Okay, if they also ask you what is the phase, guys, what is your answer? What is the phase in this case?
Sir, 0.5.
0.5. Very
0.5.
good. Okay, if I just write 0.5, not so okay. What should I write? 0.5 or radians? Meter or radians?
radians.
Radians.
Radians. This is angle, right? Check. This everything is angle. 400t. What is 400t, guys? 400t must be an angle.
Angle.
Even your 0.5 must be an angle, so it is going to be 0.5 radians. Okay, so that is how it works here. Okay, if they ask you to convert, you convert into degrees, but I don't think so that is needed. Okay, okay, now see, Aki, I think we can proceed to our next topic. Okay, your next topic is exactly your simple harmonic motion, which is already there in this question, but okay, I think we'll discuss properly now. Okay, see, your simple harmonic motion, I'll just quickly define you. Okay, a very easy one, then I'll talk later and I'll give you some more definition. Okay, so your next important topic, very important. Okay, simple harmonic motion is this. I'm going to go a bit fast today. Okay, okay, the answer is this. See, if the position of a particle can be written in terms of what function? Sine function, or what, guys? Cosine function. Okay, sine function or cosine function, then such kind of motions, okay, I'm repeating again, then such kind of motion, I'm going to call it what motion, guys? Simple harmonic motion. There is one more definition. Look at this. If the force of the acting on the object is found to be proportional to the negative of displacement, then also this such a motion will be called what? We call it simple harmonic motion. See, another way I'm writing. Okay, this is another definition. Either you say this or you say this, you will realize that all these are properties of simple harmonic motion. Okay, that means if the particle executes simple harmonic motion, then the force will be proportional to negative of displacement. I will explain to you that. Okay, but I've already explained to you this, guys, right? Check this one. You know what does it mean? That means the position and with time, right? This is the behavior of your position time graph. Then you can say that it must be what kind of motion, guys? It is simple harmonic motion because it's a sine function. Okay, if I can have that, that's the idea. Okay, I'll give you some more ways to define. Okay, so if I write, okay, if I can write the acceleration also, acceleration of the object, okay, if it is written as minus, okay, let me not write x here, let me write y because I have used y. No, if acceleration is found to be again negatively dependent on the position, okay, then also I'm going to call it what kind of motion, guys? Simple harmonic motion. Okay, see, same ideas. Okay, same ideas. Okay, one more thing, one more last thing. See, if I can write the time period, the time taken by the object to go back and forth, okay, time taken to complete one oscillation, if I can write this equals to 2 pi root over of, okay, displacement by acceleration, displacement by acceleration at any time, okay, displacement at any time and acceleration at any time. If I do this, okay, and if I'm able to get the time period, okay, then also I'm going to say that the motion is what kind of motion, guys? The motion is simple harmonic motion. So indirectly, you know what, I've told you most of the properties of simple harmonic motion, right? So tell me, what do you expect in simple harmonic motion? Tell me, guys. Waiting. what can you expect? In any simple harmonic motion, we expect that the position will be what kind of function? Sine function or
Sine function or
cosine
Sine
function?
function.
Okay,
Cosine
not 10, no chance, no 10 function. Okay, what else can you find, or what will happen? What is the property in simple harmonic motion? The force acting on the particle is found to be directly proportional to what? Negative of displacement. Yes,
Negative
this is another
displacement.
property. Okay, another property is what? The acceleration acting on the particle is equal to, sorry, not equal, proportional to negative of displacement. One more thing, the time period of the particle, if it happens to be equal to 2 pi, if I can use this, okay, displacement by acceleration, then also the object is set to execute simple harmonic motion. And you know what? I can do like this. Say, if you see that the time period depends like this, okay, or time period can be found like this, then you know what? All this automatically they will become what? True. This will become true, this will become true, this will also become what? True. So any one of them has to be true. Can you understand? Then the others are all going to follow. Did I make sense?
Yes, sir.
Okay.
Yes, sir.
Okay. Then we have one job now today. Okay, and that job is to find this. Okay, check. I think you'll agree with me. I'll take yesterday's example only. This is the pendulum I'm taking. A pendulum also you can represent as by sine function. You already know that. So this is your pendulum. I'm not going to start from there. Sorry. Okay, I'm not going to start from there. I'm going to start from mean position today. Okay, this is the mean position. See, mean position, and we know, right? How do we know the positions? Because we have another axis here. Okay, so this position, I tell you, it is y equal to 0 meters. This is extreme position. I call it y equals to plus a meters. This is extreme left, so I call it minus a meters. Okay, so this is y equals to minus a meters. Okay, so the object's motion, remember, I'm going to say it's going to the right first. That's the thing it does. So the object will appear here, the pendulum will appear here. After certain time, then let's say it is point A, this is O and this is B, no? So the motion will be from O to A, then from A to O, then from again O to B, and again from B to O. Okay, so it's going to go up, it's going to go down, it's going to go to the left, you can check. And yeah, I will talk about acceleration, whatever I was talking about. Then then yeah, what was I saying? Oh yeah, then it's going to go down. Okay, so you know, right, when the object again reaches from all this motion, it reaches back to O, right? How much time is totally gone, guys? Time spent is how much? We call it capital T. I think you're clear with this, right? We call it time period. Now the object will again go down, no? So motion will repeat after this time. Okay, so we know this, we call it a time period. Okay, now I'm going to ask you, okay, think and tell me, how much time do you think? Okay, this entire cycle has actually 4 parts. Okay, going from here to here, okay, one part, going down another part, going to the left another part, going down again another part. Okay, now again when it goes up, it repeats the motion. So yeah, okay, so I'm going to ask you a question. Okay, tell me, how much time do you think it takes to go from here to here? Time T is for oscillation or full oscillation?
Sir, 1/4 of time period.
1/4 of time period. Very good. Time taken to go from here to here will be how much? T by 4. By the time it reaches back here again, okay, what is the time? Is it T by 4 or T by 4 plus T by 4? T by 2, very good. T by 2. Then it goes here, right? What is the time to reach here? T by 4 plus T by 4 plus
3T by 4.
T by 4. So it's going to be 3 times of T by 4. And finally, when it reaches here, it's going to be how much, guys? T by 4 or 4 times of T by 4?
4T.
4 times of T by 4. That is nothing but what?
T.
T. Okay, that means it's
Time
going to reach, time period only, right? It reaches here. I think you understand, right? How I have divided this 4, not 4 motion, but 1 motion into 4 parts. Okay, so I hope you understand the timings. Okay, so that is one thing. I'm going to just rub here right now. Just remember, time here it starts with the time of 0. Here it reaches a time of T by 4. When it falls down, also it takes another T by 4. So time becomes T by 2 and so on. Okay, so I'm done with that. Let me go back and again draw the position time graph. Okay, then I'll tell you what are we doing today, Till now I don't tell you what are we doing today. So see, oops, okay, till now again I'm telling you, I did not tell you what are we doing today. Okay, see, for that I need to ask you this question, see. Okay, give me 1 second. Let's go slow again a bit, no problem with that. Okay, so I'm going to break my time now. Okay, time. Yesterday I wrote 1 second, 2 seconds, 3 seconds like that. Today I'm not going to do that. Okay, check. Tell me whether it makes sense or not. Okay, say, what's the time this one, guys? How much is the time? 0. This is position axis. So when the time is 0, right? Tell me, where is the object starting? Is it starting from maximum or starting from 0 position? In this
Zero
example,
position.
this is when the time is 0, the position is also 0. Okay, so I'm going to start from here. Do you understand? It's going to be cos or sine function, guys?
Sine
Sine
function.
function. Okay.
Sine.
Time of t by 4. Where do you expect the object to reach? Plus a, right? Yes or no? T by 2, 3 times of t by 4, and this is t. Check. I've divided the t into 4 parts. 1 part, 2 parts, 3 parts, and 4 parts. Okay, so I've divided into 4 parts. So obviously it's going to reach here, back to the mean position. Then it is going to be here, which is minus a after a time of t by 3 times of t by 3, negatively maximum amplitude. Again, it's going to come back to 0. Okay, so we know. I've drawn it yesterday, so I'm going to just draw it like that for today. Okay, now we are ready. So I'm going to now tell you what are we going to do today. See, so we know, right? Can I say this object is undergoing what kind of motion? It is
Simple harmonic.
simple harmonic motion. Okay, so I am going to start with a function right now. Okay, you check whether it makes sense or not. Okay, check. So the first thing I will automatically tell you, your yb will be equal to how much, guys? Tell me. Waiting. Y equals to how much in this example? You can tell me easily. Everything is there. Amplitude, right? Yes or no?
Yes, sir.
Then I will write sine. Then I'll tell you there must be an omega here. I will write t also, time,
Plus
and
phase.
plus phase. Okay, but do you agree in this case? Do I need to put the phase or the phase is 0 right now?
Phase is 0.
Phase is 0
Is
because yeah, because you're exactly starting from 0. Okay, and it follows sine function only. So there's nothing that has to be there. Okay, only omega t. Okay, like that. Okay, then I think you can also agree with me. Omega is obviously equal to how much? 2 pi into f. We don't know f, but we know time. See, because the graph will tell me the time. No, so omega equals to 2 pi by capital T. So we have this information with us. Okay, now we are ready. See, so let me ask you, do you understand that when the moment I write like that, okay, the equation for your position, that means what? I know the position at any time. Okay, I'm repeating again. We know the position at any time. We are going to do this now. Okay, tell me. Look at the diagram. Okay, tell me. Okay. Then everything will make sense. Okay, check. Okay, check. Okay. Tell me. This is in this position, in this time, right? 0 is the time. Position is 0. When it reaches here, we know the time is t by 4, and the position is how much, guys? Plus a. When it goes back here, we know the position is what, and we know the time also. Okay, and when it reaches here, a different position, a different time. Okay, when it reaches here, different position, different time. Okay, my question to you is this: say, is this object, while it goes from here to here, okay, does it have in all these positions, okay, in all these positions, does it have same velocity or different velocities? Different velocities. Okay, just tell me here, what do you expect the velocity to be equal to how much?
Zero.
0. Very
0.
good. Okay, yes, very good. Here, what do you expect at this point, the velocity to be equal to how much?
Maximum.
Maximum. Yes,
Maximum.
that means at different time we'll have different velocity. Yes. Okay, here also what do you expect the velocity to be equal to?
0.
Zero.
And here what do you expect, guys? Acceleration is maximum, or let me use capital A. Okay, I hope you understand why I'm using capital A. Capital A is for acceleration, small a is for amplitude. Okay, so what kind of acceleration I told you are going to expect here, guys?
Maximum.
Maximum acceleration. Very good. And here what kind of acceleration do you expect?
Minimum.
Zero acceleration. Why? Because
Zero.
once the velocity becomes maximum, okay, so at that moment, the moment I tell you the velocity is maximum, that means what? It has changed and it has become maximum. So there is no change at this particular location. So if there's no change in velocity at this particular location, the acceleration is 0.
Zero.
Okay, and here again, when I
Zero.
come back, acceleration becomes how much? Maximum. Okay, so now you will agree with me. Okay, you will agree with me that, can I tell you that acceleration also depends on time or not?
Yes.
At different time, the position is different. At different time, the velocity is also different. At different time, the acceleration is also different. So I'm going to write here, acceleration is a function of what? Time. Agree, right? Even velocity is a function of what? Time. Okay. In other words, I can also tell you now like this. Say, since position is also a function of time, right? I can indirectly tell you that acceleration can also be written as what? Function of what? Position. And velocity also can be written as what? Function of what?
Position.
That means
Position.
I'm going to write the formula between acceleration and what? Position. That means at what position what will be the acceleration, okay? And even I can do with velocity also, okay? At what position what will be the velocity? That is the formula we are going to derive right now, okay? So please check. That is what we are going to do. So first of all, I'm going to calculate velocity, okay? Check. If you don't understand, you can ask me, okay? If you have any problems, of course, okay? So let's start, okay? Say, so let's find first velocity, okay? Let me quickly check my notes also if I have done in this way only. Give me just 1 second. Not 1 second, I'm going to take 2-3 seconds. Why are the students leaving? As some students are just joining and leaving, huh? These people को धुलाई देना पड़ेगा रे प्रॉपर का. Where is it? Oscillations and waves. Simple harmonic motion. Okay, yes. I got it, okay. So yeah, I will send you this today only. Check. Oh yeah, I need to also explain to you. I did not explain to you what is the meaning of F is proportional to what? Minus of y. The force acting on the object depends on the negative of displacement. Okay, so let's try to understand that. Say, okay, I'll do that in a different diagram. So I want to really explain to you this part right now. Okay, check. Then I'll go back and calculate the velocity and acceleration formulas. Okay, and we have to draw graph also for them. Okay, so now say, check. Okay, if the object starts from here and goes in this direction, this is the first part of the motion. Okay, this is the direction of what, guys? What do you think? That's the direction of what? Do you agree that's the direction of displacement or not? Yes.
Yes, sir.
Okay, this is the direction. Okay, to the right is the direction of displacement. Is it positive or negative? What do you think? Positive displacement wave.
Positive.
Okay, I'm going to ask you a question. Okay, tell me the direction of, okay, in this direction what do you get? You get acceleration or retardation?
Retardation.
Very good. In this direction, when the object is climbing up, you get retardation. That means the direction of acceleration is what? This one. Can you understand?
Yes, sir.
If this is the direction of acceleration, then obviously this will be the direction of retardation. I can show you here also. See, when I throw an object up, what do you think is that? Direction of acceleration or retardation? Retardation, negative g. But this is what? Direction of positive g. Positive acceleration. Okay, and this is negative acceleration. I hope you understand. The same logic goes here also. Okay. Okay, so this is the direction of acceleration. Okay, do you agree that this also will be the direction of force or not?
Yes, sir.
Okay.
Yes, sir.
Now let me tell you, what does it mean? Do you agree that now the direction of force will be such that it will be proportional to displacement or negative of displacement? Negative of
Displacement.
And why did I write like that? Okay, also I'll tell you. If your y equals to 0, what do you notice, guys? What is the amount of force acting on the object? 0. Let me tell you why. Say, if the object is here, how much the object accelerates here? 0. No acceleration, no retardation, nothing. Okay, so force also must be equal to what?
0.
But once the object starts going up and up and up, don't forget y is increasing, right? Check. Is y same or increasing? Y is increasing, and if y increases, the object goes up and up and up. Okay, and what happens? Your force also increases. And what do you think this force is trying to do, guys? This force is trying to let the object go away from the mean position, or the force is trying to bring it to the mean position? What do you think?
Bring it to the mean
Bring it
position.
to the mean
Okay,
position.
and that is like a restoring force. Okay, always the object, okay, will go left and right. Okay, but the intention of the object is to what? Always come back to the
Mean position.
mean position.
Mean
Okay, so
position.
that is why I'm telling you again, the force will act negative or displacement. Okay, let's check again. Say, if the object, okay, is going to go down like that, okay, what do you think is going to happen? Okay, let me just put in this way. This is the direction of what? Displacement, right?
Displacement.
Displacement. This is the direction of what?
Acceleration.
Acceleration, okay, and this is the direction of retardation, okay. I hope you got my point, okay. So do you agree that more is the value of y, more is the value of y, will the force be acting or more force will be acting to bring it back?
More
More
force
force
will
will be
More force.
acting, yes, okay, that's why I'm writing this formula, okay. So yeah, this is also one part of it, okay. I'm done talking about this, okay. I think I can now go back, okay. Here, say, so yeah, I have written the equation for this graph, that is y equals sine a sine omega t. Now I'm going to derive all these quantities, okay. So please check, I'm going to start, okay. So tell me, how do you find the velocity? Waiting, that's the first thing I told you we are going to do. How do you find velocity, guys? Number one. Oh, by the way, I'm finding velocity or instantaneous velocity. What is this? Position or instantaneous position?
instantaneous
Instantaneous
position.
position.
Instantaneous position. Position at any time. So I'm going to also find velocity at any time. Okay. So formula is what, guys?
dy by dt.
dy by dt. Yes. Change of position with time. Okay. So I'm going to really differentiate it. Okay. So waiting. Help me out. V equals to what? Differentiation with respect to time. Change of position with respect to time. But position I've already written a sine omega t. Okay. So I'm going to write it back here. Okay. So tell me. I'm going to write a sine
Omega
omega
t.
t. Okay.
Omega
Now
t.
you are going to identify. Okay. What is constant here?
Amplitude.
Amplitude. Because I'm saying that every time the object oscillates, it always reaches how much? Plus a, plus a, plus a, plus a, plus a. Okay. So that means what? Amplitude is constant, right? You always reach to the same maximum. So amplitude is constant. That's our assumption right now. Okay. And then in real life it doesn't happen. Okay. I know that. Because you know, right? Slowly the swinging will stop, right? Okay. That is because of damping. That's a different case. But for the timing, I'm assuming it to be constant. Okay. Look at this. What do you think? What does it mean? Amplitude is constant or amplitude is decreasing?
Amplitude is
Okay, yeah, oh yeah, okay. That means it went to plus a, but now it has not gone to plus a. It has gone less than plus a, less than plus a, less than plus a, less than. Slowly, it's going to die out. No, this is the oscillation. Okay, so this is not what we are talking about. Okay, this is what we are talking about. Every time object reaches constant amplitude. Okay, so this is constant. Omega also, I'm saying omega is also what? It is a
constant.
that means the
Constant.
amount of time taken to go back and forth doesn't change. If today, okay, the object is going back and forth taking 2 seconds as the time period, then omega will remain 2 seconds, 2 seconds, 2 seconds, okay. So omega is also constant, but of course t is not a constant, okay. So the first step here is what? You take out the a, which is a constant, and you write what? Differentiation of what is inside?
Sine omega t.
Sine omega t. Okay, so this is what we have. Now you really have to learn a new differentiation formula. Okay, I'm going to write it on the side. Check. First of all, let me write differentiation, okay, of not with, okay, let me do with time only. If I only have sine t, okay, because t is time only, if I have only sine t, so what is the differentiation? Anybody who knows? Differentiation of
So
sine
is it cos t?
cos, yes, very good, it is cos t. Okay, differentiation of sine is cos t. But look here, if I have differentiation of not just sine but sine omega t, please remember I have an extra omega here with time. You cannot just separate it, okay. In that case, again you are going to write cos, but this time don't write cos t. What will you write? Cos omega t.
Omega t.
So do you understand, guys? I've just applied, right, the differentiation. This is, I told you, you are going to learn in class 12, huh? So for today, just the formula, that's it. Is it okay, guys? Just check.
Yes, sir.
Okay.
Yes, sir.
Then, but also one more step, okay. You just cannot keep cos omega t. You have to multiply in front with omega. This extra thing that you have, no? You really have to multiply in front, okay. Then of course I'm not going to give you any explanation right now, but remember this is how it's going to look like. If it's only cos t, this is what we have. Oh sorry, sin t, this is what we have, cos t. But if it is sin omega t, it's going to look like this, okay. This extra omega you have to write in front, and then of course the whole sign will become cos, okay, and omega t of course you have to write. So that's what I'm going to use here. So please help me out now. So v will be equal to how much, guys? Tell me. Amplitude. Differentiation of sine is what I told you just now. Cos omega t,
Omega.
but omega is an
Omega t.
extra with the t, right? Okay, then I should write the omega outside, right? Is it okay, guys? Check.
Yes, sir.
Okay,
Yes,
now
sir.
I'm going to ask you, what is this called, guys? What do you think is this? Is it velocity or velocity time relation?
Velocity time
Velocity.
Velocity time relation.
Time relation. Okay, and I can draw this graph. I will show you exactly, okay, how much this graph is going to rise, guys. Tell me. Is it going to rise till 1 or going to rise up to a omega?
A
A omega.
This is in front of cos. That means if there was nothing here, right, The graph will rise to how much? 1. It will rise
1.
to 1. But there is a omega here. So the graph will rise up to how much? A omega.
A
Okay.
omega.
So now please tell me, what is the maximum velocity I'm talking about? How much is the maximum velocity?
A omega.
A omega represents maximum velocity. All of you agree or not? Yes or no?
Yes, sir.
Okay.
Yes,
A omega represents maximum velocity. That is one of the thing. Okay. Now obviously I'm going to just arrange it. I'll do that. But I want to draw a graph for this first. Okay. So please help me out. This graph is going to look like cos function because we have cos omega t. Okay. And this function, this velocity function will rise up to how much? A omega. So I'm going to go back to my graph. Okay. And where is that? It is here. See. So I'm going to really draw it. Okay. Now let me show you down here. Okay. See. Give me some time to draw the graph. Oops. Check. Okay. So this is going to be our graph. Let me just extend this line also a bit. Okay, timing, I'm taking same timing. Check. Okay, this is t by 4. I'm just going to have in the same time. Okay, I cannot just change that. This is time again, and I am ready to plot velocity. Okay, so what is the maximum I can go, guys, for velocity? How much maximum? I told you a omega, and the other one will be minus a omega.
A omega.
Minus
This
A omega.
means you are going what? To the right with the maximum velocity, and this means you are going to the left with the maximum velocity. But it doesn't happen all the time, right? It happens every time or at certain times. Yes.
At certain time.
At only certain times. Let's check that. Okay, check. Agree or not? Check this graph. Check. Okay. Is this graph clear, guys? Check. First identify, is it a sine function graph or cosine function graph?
Sine function.
Cosine function.
Cosine function. Okay, yeah, makes sense because our velocity, this is now velocity time graph. Okay, so this is velocity. See, velocity time graph. This is negative velocity, that is positive. So this is okay. Now please identify, what is this? T equal to how much here?
0.
0.
Now let's come back to our diagram here. When the t is 0, do you agree this is the object here or not?
Yes, sir.
And what kind of velocity do you expect?
Maximum.
Maximum. That's why look at the graph. The graph is also is maximum for the velocity there. Okay, makes sense, right? Check.
Yes, sir.
Okay.
Yes, sir.
This time is how much here? T by 4, right here? T by 4. Where is the object t by 4 later, guys? The object is here or not?
Yes, sir.
Okay. And what is the velocity there?
0.
0. Yes. Okay. So that's why look at the graph. The graph is going down to what?
0.
0. And do you understand all of these values? Okay. Are they values of positive velocity or negative velocity?
Negative.
Negative? This is itself is velocity of the graph. This is positive velocity and this is what?
Negative.
So all these values of velocity are what?
Positive.
Positive. Okay. And the object is going to the right or the left?
Right.
Right. And it does that, right? Check. From 0 to t by 4 it goes where? To the right. So all these velocities are what velocities? Positive velocities. Okay,
Positive
I'm
velocity.
done right now. I don't want to talk more than this, guys. But did you really understand or not what is happening?
Yes, sir.
Okay. So if I ask you, okay, if I tell you the time, now you should be able to tell me what? The velocity at any
Time.
Okay, this is not 3t by 4, sorry, but this is what? T by 2. Here it is going to be 3 times of t by 4, and here is going to be capital T. Okay, so this is what's going to happen. See. Okay, so I'm done. Okay, I don't need to talk about more than this, but I want to change this formula a bit. Okay, I don't know where it is. Oh, here. Okay, so I want to change this. This time I want to write relation between velocity and position. Okay, relation between velocity and position. Okay, for that I'm going to follow this method. Check. Okay, V equals to a omega cos omega t. Everybody's clear? Same thing, doesn't no change. Okay, but I just want to change it this way. See, I can write a omega instead of cos omega t. What can I write, guys? 1 minus square root of
Sine
sine square omega t. I
square
think this
omega
part, this one you have seen since class 10, because sine square theta plus
Cos
cos
square
square theta
theta.
equals to
Square theta is equal to 1.
yes. Okay, so cos square theta will be equal to how much?
1 minus sin
sin
square
square
theta.
Sin
Sin
square theta.
square.
So cos theta will be equal to root over of 1 minus
Sin
sine square
square.
theta. So
Sin
that is
square
what I've
theta.
used. You can check. Okay, in place of cos, I can write root over of 1 minus sine square theta. So I can write that one. Okay, you got my point. Okay, although I'm speaking fast, I think it's fine. Okay, now one more step I'm going to do. Okay, check. V equals to, I'll write here omega, but a I will bring inside the square root. So inside the root, this a if I bring, it will be a or a square, guys.
A square.
A
A
square.
square. So 1 minus sine square omega t. I hope so. I am doing fine. V equals to omega, right? And root over of a square multiplied with 1 is a square minus a square sine square omega t. Okay, and then V is equal to what? Omega. Now please identify. What can I write? In place of a, I'll write a square only, no problem. But what is this? Okay, what is y? A sine omega t. So what
Omega
is
t.
y square? A
A
square
square sin
Yes,
sine
square
square
sin
omega
omega t.
square
t.
So do you understand all of you that this is nothing but what square? This is nothing but y square,
Y
right?
y
square.
square.
Now you look at the formula. Look at the formula. Tell me what is this now? Is it position time relation, velocity time relation, or velocity position relation?
Velocity
Velocity
position
Velocity
relation.
position relation. Okay, let's apply it. Okay, suppose I come and tell you at position called y equals to 0. Tell me, where are you? Mean position, right? Yes or no?
Yes, sir.
Okay.
Yes.
What will this formula give me? Velocity will be equal to how much at this position? Omega root over of a square minus 0.
A
Do you
square
understand, guys?
minus
Check.
0.
A square minus. All of you understood this one? Check. This formula means
Yes,
put the
sir.
value of position, get the value of what? Velocity.
Velocity.
Okay, so
Velocity.
I've done that. Okay, I have put the value of position, which is my mean position, and I should be getting the value of velocity. I did that. Okay, I put y equal to 0 here, say. Okay, so now I'm going to get equal to how much? Omega root over just a square. That is nothing but what? Omega into.
Omega A.
Okay, and we know what is this? It is just velocity or maximum velocity.
Maximum
Okay,
velocity.
so when do you get maximum velocity? I can just tell you directly, right? Which position?
At the
Mean
mean position.
position.
At the
Mean
mean
position.
position. Okay, so yes. Okay, see how that's how we get it. Okay, let's apply again. This is number 1. At number 2, at let's say y equals to plus a or let's say minus a. Okay, let's put plus or minus, doesn't matter. Okay, so let's check. So what will I write? V equals to what? Okay, what is this, by the way? This is mean position or extreme position?
Extreme
Extreme
position.
position. Okay, so at extreme positions to the right and left. Okay, so what will be our formula, guys? Root over of a square minus, in place of y I'm going to what? Put what? Plus a or minus a.
Minus.
So I'm going to write plus or minus a, but I have to give what, guys? Square.
Square.
But we know whenever I put square, right, doesn't matter whether you put plus or minus, I'm only going to get what? Plus.
Yes.
So that is going to be equal to how much? 0,
Zero.
because a square minus a square, doesn't matter, you put plus or minus. Okay, I'm going to get 0. So what does it mean, guys? Velocity is how much?
0.
Zero.
At
Zero.
which positions?
Position.
At extreme positions.
At
Okay,
extreme
so
position.
yeah, very good. And this is another characteristics of what? Simple harmonic motion. This will happen. Okay, that's what we're actually dealing with. Okay, guys, all of you, are you clear with whatever I've done just now?
Yes, sir.
Okay, I'm going to take
Yes, sir.
1 minute, not 1 minute, 5 seconds to ask. Please respond quickly so that I can go to acceleration now. Okay, so I'll go for acceleration now. How do you find acceleration, guys? Please tell me. Rate of change of
dv by dt.
Velocity.
dv by dt. Okay, I'm again calculating instantaneous acceleration. That means I want to know at what time what will be the acceleration. Okay, yes, so I'm going to use that. Okay, for that I'm going to go back and use this one. Say, don't forget, this is called velocity time relation, and I can directly come and plug in this over there. Okay, so a omega cos omega t. Okay, check. So I'm going to write d dt of what, guys? A omega cos omega t. This is a velocity time relation. I'm using that. You cannot use velocity position relation, otherwise you'll end up with problem, no? Because you have to bring time. Okay, so tell me now again, guys, which one is constant here?
A omega.
A is constant, omega is constant. So what will be inside the differentiation?
Cos
Cos
omega
Cos
t.
omega t. Now you are going to tell me. Okay, so acceleration equals to, okay, a omega. Let me now give you again new formula. Differentiation of cos t. Your answer is, don't forget, minus sine t.
Minus sin
Is
t.
it agree? Not is it agree? Do you agree? Is it
Yes,
fine?
sir.
Is it fine?
Yes, sir.
Yes, sir.
Okay, so differentiation of cos omega t. Now tell me, what will be the answer? minus
Minus sine
Minus
omega
omega
t.
sine omega
minus
t.
sine omega t, and of course I'm going to have an extra
Omega.
Omega.
omega in front. So I'm really going to use this one over here because that's our function inside the differentiation. Okay, check here. Okay, so I'm going to proceed. Okay, check. Tell me, waiting. Minus omega sine
Sine omega t.
omega t. Okay, and now we just need to arrange. So I'm going to get a minus sign. A will be there, but this time I'll get omega or omega square.
Omega
Omega
square.
and sine omega t.
Omega t.
Okay, so we got, what is this now? Tell me, is it position time or acceleration time relation?
Acceleration time.
Acceleration time relation.
Acceleration time relation. Okay, that means you put the value of time here and get the value of what?
Acceleration.
Acceleration. Okay, I'm also going to write acceleration position relation. That's very simple. I don't have to do much here. See, acceleration will be equal to minus, this is a, and what is this? Sine omega t. And you already know what is a sine omega t, right? A sine omega t is nothing but what?
Position.
Y.
Yeah, y. So I can write omega square what? Y.
Y.
And notice something I've proved already, right? Acceleration is proportional or proportional to minus of y.
Proportional to minus
Ah,
of
so
y.
this
minus
is,
of
I told
y.
you, it's a property of acceleration, right? I told you. Even force, right? Force will be what? Mass into acceleration. So I can write m into what? Minus
Minus
omega
y.
square y, right? Check.
Omega square y.
So I can write here what? Minus m omega square y. So that will be a force. And now I can tell you your force is proportional to minus of what? Y again. Okay. So this is how you are proving. Okay, how does acceleration depends with position and all. Okay, and this is how acceleration depends on time. Okay, I'm done talking about this, but I want to draw the graph again for acceleration. Okay, so can you think and tell me how high the acceleration graph is going to rise?
A omega square.
A
A
omega
omega
square.
square.
So please tell me, what is the maximum value of acceleration? It is a omega
Omega
square. That's the maximum
Square.
value of acceleration I will get in any simple harmonic motion. Amplitude, angular frequency squared. Okay. Now you tell me again. Okay, what kind of graph is this going to be, guys? Is it going to be sine graph or minus sine graph? If I want to draw the graph,
Minus.
minus sine.
minus sine
Minus sine
graph.
graph.
I will show you how does a minus sine graph looks like. Then you will be clear. Okay, so let me go back to our graph. Am I speaking very fast, guys, or is fine? You're following?
Yes, sir.
Yes, sir.
Okay. Anybody who doesn't like my speed, please tell me. Okay, today I'm really fast, no? Okay, but sometimes fast is also good. Anybody having problem with my speed, please let me know. Okay. Before this I was much faster. Okay, a few years back, too fast. Okay, I was like a rocket, but these days I have become a bit slow. Okay, Jyotirmoy joined again. Okay, let's go to these timings again because it will help us. So I'm just going to draw this reference line here. This is t by 4 line. This is t by 2 line. Okay, this is 3 times t by 4, just like that. I'm just going to use it for the time being. Okay, so please help me out. So I'll show you something now. Okay, check. If I draw a graph like this, you know what is this, guys? Is sine or minus sine graph?
Sine graph.
Sine graph. So look at minus sine graph. Minus sine graph will look like this. Say, can you understand the difference between sine and minus sine graph, guys? Check. Okay.
Yes, sir.
Wrong. It's correct till now. Okay, then it will go till here and then go there. No, I think you understand, right? The red one is what? Sine or minus sine?
Minus.
Minus sine.
Minus
Minus
sine.
sine. Yes. Okay, so this is what we get. Now you decide. Okay, this is acceleration graph now, and this is minus acceleration graph. You can understand, right? Between time from t by 2 till t by 4, tell me what kind of acceleration the object has, positive or negative acceleration?
Positive.
Positive values of acceleration, yes. And between 0 and what?
2 by 2.
Okay, so it's like that. I think you got the point. I'm not going to explain more than this right now.
Sir.
Yes.
So omega we can write 2 pi f and 2 pi 2 also, no sir? 2 pi t, I mean.
2 pi t or 2 pi by t?
2 pi by t.
2 pi by t. Yes.
And we can write 2 pi f, no sir?
Yes. Omega is angular frequency. So you take 2 pi, you multiply with f, you get angular frequency. Or you can also write omega is equal to 2 pi. In place of f, I can write capital T. Say 1 by t.
Okay, sir.
Okay. So now
Yes,
please
sir.
tell me, guys. Okay, at which positions? Please check. This corresponds to acceleration or maximum negative acceleration. maximum, negative, acceleration. Correct? Check guys. Yes.
Yes.
Okay, and this corresponds to what? Maximum
Maximum positive acceleration.
positive acceleration. Okay, without looking anywhere. Okay, can you tell me what will happen when the acceleration is maximum? Velocity will be how much? 0, right?
0.
Check, go back, you can see here, see the velocity is what? 0. Okay, go back up there, see what is the position? Maximum, negative. Do you understand?
Yes.
Maximum, negative. Okay, yeah, so you can go back up and to the graphs and all, you can see all those things. Okay, look at this, what is happening here? Tell me, what is the acceleration, guys?
0.
0.
That means at that moment velocity has become how much?
Maximum.
Maximum.
Velocity becomes
Negative.
maximum. And which position it happens? You can go back
In
here,
the
see.
mean position.
In the mean position, see. So all these are related like that. Okay, but I think you got the idea of what this graph is. Okay, guys, can I say you really understood today's class?
Yes, sir.
Okay,
Yes, sir.
I'll send you these notes. Okay, all these things. Now I have only one topic left. Okay, and I need to show you this. Please check. I told you the time period in any simple harmonic motion. How do we get, guys? Formula 2 pi
Root over of displacement by
Displacement by acceleration.
Very good. Acceleration, displacement by acceleration. So how to reach here? I'm going to show you that. Okay. So now think and tell me. Okay, check. Can I go back and use this one or not? Please check. Okay, I'll show you which relation I'm going to use. Alright, I'm lost. Where is it? Oh, here. Okay, I'm going to use this relation. Okay, what is A, guys? Minus omega square y.
Why?
Okay, I'm going to use this relation right now. Okay, so I'm really going to use this. Please check it makes sense or not. Okay, I'm going to write A equals to omega square y with a minus sign. Okay, I'm going to really bring it. Where is acceleration? I wrote somewhere. I wrote, oh, here. So I really want to prove this one. Okay, so I want to use this one. Then you know what? I'm going to write like this. Okay, I'm going to write omega square is equal to what? Tell me, guys. Acceleration by y, but I'm going to
Y.
get what sign? I'm going to get what sign?
Minus sign.
A minus sign. Okay, then let's really change it. Okay, if you notice, I can just talk about here in this entire expression. I don't want to know the relation between the direction of a and y. A is a vector, y is a vector. So yeah, plus and minus makes sense for them. Okay, but omega, tell me, okay, is omega a vector or not a vector?
So not a vector.
Not a vector. Omega is 2 pi f. Frequency is not a vector. Frequency is inverse of time period. Time period is not a vector. So that means omega is not a vector. So it is what? It is a scalar.
Scalar.
And what kind of scalar is omega, guys? Is it a positive scalar or negative scalar?
Positive.
Positive. Omega cannot be written as minus 10 hertz. Wrong. Or radians per second. Wrong. Frequency cannot be written as minus 20 hertz. Doesn't make sense. You have negative 20 oscillations per second. Wrong. Totally wrong concept. So your omega or f are never going to be what? Negative. So if I want to write this expression, see how it works out. Okay, omega will be equal to what? Omega square will be equal to a by what? Y. And I can just omit what? Omit the negative sign, because I want to talk in terms of what? Acceleration, displacement, or I want to talk in terms of right now what? Omega. Can you understand? Is it all
Yes,
right?
sir.
Okay, so check now. Okay, so omegas can be written as what? Root over of acceleration by
A by y.
acceleration by
by
displacement, and now everything is clear. 2 pi what? By t will be equal to what? Root over of a by
A by y.
and I can just arrange it. I can write t by 2 pi equals to what? Root over of y by a.
Y by
I've
A.
just reversed it. You can see like that. So t will be equal to how much? 2 pi root over of y
root over
by
of a by a.
y by a. So done. Okay, I have proved this also. Okay, so this is a 7-page notes that I'm going to send you. Okay, so please check. I think there's one more thing I need to do. Okay, I think better I finish it today only. Okay, because I'm going so fast and with very nice pace, I think. Okay, so I'm going to go and show you the next one. The next one is not going to be so easy. Okay, I'll tell you what is that. Please check. Okay, I think I should do it right now only. I'm going to now calculate something called total energy. Okay, this is the last thing I'll do, and then I'll send you questions. Okay, numericals. Okay, so please check. This is the last thing. Okay, guys, check. I'm going to calculate something called what? Total energy in what? Simple harmonic motion. So whatever we have done today, no, they can just ask you this, all these things, okay? They may ask you to derive position time relation, velocity time relation, acceleration time relation, acceleration position relation, velocity position relation, or they may also ask you find the expression for total energy in if a body is executing simple harmonic motion, okay? So that is what we are going to do right now, okay? Check, the idea is simple, okay? Say, if you notice the pendulum, again I'm going to take this as an example. Just look at any position. It may go right or left, but let's say it's going down right now, okay? So this is just any position called x right now, okay? My question is this, say, tell me, this is y equal to 0, this is y equals to plus a, it is not there, it is somewhere here, less than a, no problem with that because it's going down maybe. So it is there right now, okay, at any time. My question is this, okay, tell me, does this object has kinetic energy or not right now? Yes, waiting.
Yes.
Okay,
Yes, sir.
it has kinetic energy. What will be the formula of kinetic energy? Half mass of the
MV.
object and velocity square of the object. Do you understand that I already know how does velocity looks like or not? We know, right, how does velocity looks like? What is the formula for velocity? Okay, so can I find kinetic energy or not, guys? Tell me.
Yes, sir.
Okay, so help me out. What is the formula? Half m and velocity. Who remembers the formula for velocity? Omega. Let me help you out. Omega root over of a square minus y square. Do you remember this is the formula for velocity, right, guys? Check.
Yes, sir.
Okay, we got it. Okay, you have
Yes,
to
sir.
check. Okay, this is the formula for velocity. So if I square it, this will become velocity square. So what is the kinetic energy of this object at this position, guys? How much? Half m. I will write omega or omega square.
Omega square.
Omega square, and then this brackets will be gone. So it will be a minus what? Y square. Okay, so this is the kinetic energy. Please try to understand how to read the formula. This represents what, guys? This is the kinetic energy of what? Of the body executing simple harmonic motion at position or at any position.
At any position.
Yeah, if I put y equals to 0, what do I mean by that? I can find kinetic energy at mean position. What will be equal to that? Tell me, guys, how much at the mean position?
Half m omega
Half
square a
Half,
square.
very good,
square, a
half m
square.
omega square and directly a square because y is 0, no? This is the kinetic energy at which position? Mean
Mean
position.
position.
Okay.
So can I repeat again?
Yes, tell me, where are we? Which part do you miss? Did you miss?
From kinetic energy, second line.
Second line. Okay, check. Okay. Do you understand this formula? Kinetic energy. Sorry, velocity. Check.
Yes, sir.
Okay, then see. So when I square, no, the square with the omega will become how much? Omega square.
Sure.
Okay. And the root here, right? Because of the square, will there be root or no more root?
No root.
No root. So what is this? You know, this is the formula for what? To calculate kinetic energy at position or at any position y.
Any position.
At any position y. That's why, see, I'm just calculating some extra things now, okay? I'm calculating what will happen in mean position. Mean position means y equal to how much? 0. So you come and put y equal to 0 in this formula. That means I'm not going to have this term here, right? Check.
Yes, sir.
So it's going to look like this. Okay. Now it's clear. Check.
Yes, sir.
Okay. Now who can tell me? What do you think? This is kinetic energy or this is maximum kinetic energy?
Maximum kinetic energy.
Okay. Because in the mean position, do you agree or not? The object is
Velocity
faster or
is
fastest?
maximum.
The velocity is
Maximum.
maximum. So
Maximum.
this is what is happening. Okay, your kinetic energy is maximum. Okay, then waiting. Help me out. Y equals to where I'll calculate plus minus a means I'm going to calculate the kinetic energy in which position, guys?
Extreme
Extreme
position.
position. Okay, so I'm going to come back to this formula and put y equals to how much here? Plus or minus a. Okay, and now you can directly tell me what will be kinetic energy. Directly tell me, guys. Yes, equal to how much?
Half m omega square.
Okay, 0.
Oh.
Directly if you tell me 0, right? Because
Yes.
here I'm going to put a right, in place of y. So automatically I'm going to get how much? 0. Okay, so don't worry, we got a formula for kinetic energy. Okay, and for that I'm going to use this one. See, so what does it represent, guys? Does it represent kinetic energy extreme or mean or at any position?
At any
At
position.
any position. Yeah, I'm going to use this. Okay, I am not going to derive for time. no need to, I don't need to do that. You can write time also, because you can come back and replace y by what? A sine omega t. That will represent a kinetic energy and time relation, right? If I use this here, right? Check. Okay, if I use this here, a sine omega t, then it will represent kinetic energy and time relation. Okay, but no need for the time being. Okay, now one more thing. Okay, yeah. How do I find potential energy, guys? Because this object, okay, do you agree it has potential energy or not at different positions?
Yes.
Okay, potential energy, I'll tell you how it is measured here. Okay, here with respect to this point, okay, at this point, this is the lowest height, right? This is what this region here, right, which I'm shading. Okay, this represents height or lowest height of the object.
So lowest height.
Lowest height. So in one way I can tell you, right, this corresponds to energy or lowest potential energy.
Lowest potential
Lowest.
energy.
Okay, and x, okay, y equals to plus or minus a represents to height or the maximum height.
Max height.
Maximum height, yes. Okay, so this position, right, will represent potential energy or maximum potential energy.
Maximum potential
Okay,
energy.
okay. Did you realize something? In this position, the kinetic energy is 0, but potential energy is maximum. In this position, what happens, guys? Kinetic energy is what?
Maximum.
Maximum, yes, but potential energy is 0. Do you
Zero.
agree that if the object is keeping on falling, right, what happens? The potential energy is converted into what energy?
Kinetic energy.
Kinetic energy, yes. And when it goes up, okay, when it goes up, what is converted to what?
Kinetic energy to potential energy.
Very good.
Potential
Kinetic
energy.
energy is converted to potential energy. I think all of you understood. Am I speaking very fast? Some of the students really left. Okay, I think they are angry. I don't know. Okay, but are you clear, guys? All of you?
Yes,
Yes,
sir.
sir.
Okay, those who are present
Yes, sir.
listening nicely, I think it is.
Yes, sir.
Okay, fine. Okay, now check. I think Vinayak. Okay, Bajrohin is saying yes, she's clear. Elishiba is there. Okay, Demaya, new student, is clear.
Yes, sir.
Okay, Demaya, I don't know. Okay, your school, will they said anything? They'll finish this topic.
No, sir, they didn't say
They
anything.
did not say anything. Okay, fine. Then Sahanas is also there. Sahanas is clear. I hardly,
Yes, sir.
okay. I hardly talk to Sahanas, no. Then Polomi is there today. Polomi messaged me something about something. I forgot. I have to check again. Polomi messaged me about what?
Sir, the notes on Carnot cycle.
Oh yes, notes on Carnot cycle. I really did not.
Yes,
make it.
sir.
I have to sit and make. Okay, please give me time. Okay, today I'm so tired. I had 3 tuitions at home. Then now again another tuition. So tired. Okay, for today and tomorrow, huh? Okay. Follow me. So please, sorry. I will send you by
Yes, sir.
2 days. Give me 2 days. Okay. Then this today's topic I'll give you today only. Okay. Now check. I want to calculate potential and energy at any position. Check how it is going to work out. Okay. There are 2 ways to show you. I want to show you 2 ways. But yeah. I will show you one way first. Okay, of course. So how to do that? Okay, I want to calculate potential energy. Please always remember, okay, I'm telling you this, if you can remember is fine. If the force acting on the object is equal to 0, if the object is not experiencing any force, then the potential energy is found to be equal to how much? 0. The object really need to experience what, guys? Force at that position, okay, in order it to have potential energy. I'll give you an example. Okay, I'll give you an example. See, look at this. This is a spring, okay, at rest. Nothing is happening at rest. Very nicely it's sitting. Okay, I attach a mass here, so nothing is happening right now. Okay, now tell me, this is an equilibrium position. This is the most stable position of the spring. It doesn't oscillate, nothing. Okay, so please tell me, okay, what is the force acting on the mass because of the spring? What is the force? 0. Agree with this? Check.
Yes, sir.
I have not compressed the spring. It is just like that. Okay, you just take any spring. No, don't compress it, don't expand it. Okay, so what is the force acting on the spring right now?
Zero.
Do you agree with me that the potential energy, right, will also be equal to how much?
Zero.
Because you know what? In this position, if I keep the mass or the spring, can it do any work or it cannot do any work for us?
Cannot.
Cannot do any work. What does it mean? Cannot do any work means it cannot oscillate. It cannot oscillate. Doesn't have anything, right? It doesn't have kinetic energy also potential. It doesn't oscillate, nothing, right? But look at this. If I take the same thing, but I change the position, okay, check. I change the position of the mass, I bring it here. Now you tell me, okay, is it same or different position? Check, guys.
Different position.
Different position, yes. Will the spring look like that or the spring will be expanded now? Or stretched?
Stretched.
Stretched, yeah, the spring is stretched now, stretched. Do you agree with me that the spring wants to go back or not?
Yes, sir.
So what
Yes,
is the force acting on the spring? Yes. Is the force acting on the mass? Yes. So this force is called force or restoring force?
Restoring force.
Restoring force. Agreed? All of you, check. Yes or no? Is the force acting now or not? Check, guys, in this position. When the mass was here, let's say position equal to x equal to how much? Or y equals to 0. Let's say this is position y1. Okay, tell me, guys, in this position, does this spring has energy or no energy?
It has energy.
It has energy because if I release my deforming force, the moment I release now, this will happen. See, the mass will go back, oscillate, cross the mean position, again oscillate, go back like this, right? So did you understand that at certain position there may be force and there will be potential energy? At certain position there may not be any force like this one, and the potential energy here also will be also equal to how much? 0. Okay. I think you got my point. Is it okay, guys? Check.
Yes.
Okay, just
Yes,
ask
sir.
yourself at which position the spring can oscillate. It is this position here. Here also the spring can oscillate, but here the oscillation will be with same energy or less energy here. What do you think?
Less.
Less potential
Less
energy.
energy.
Here the energy will be same, or the force will be high or low here in this position. Force
No.
low, less force, and even potential energy will become less. Okay, I think you got my point. Okay, same idea goes here also. Okay, so now please try to understand this idea. Okay, please, very important, huh? If you understand this, I'm done. Let's not be lazy today. I'll not take a break also. Okay, check. Right now I'm saying this is the position of the object, this one, not extreme position. Extreme position is this one, certain position. Okay, and what is this position I'm calling, guys? The value of this position at any time is how much? Y. Is it okay? Check, guys.
Yes, sir.
Okay, right now this is the position of the object. I am going to, okay, take this object from this position to this position. Okay, so what kind of displacement do you think I'm making it suffer? Is it a very big displacement or very small displacement?
All is small.
All
Very
displacement.
small. Can I call it dy? Check.
Yes, sir.
Okay, now from a position called y, here I'm taking the object from here to here. Okay, let's say it wants to go down, no, but I'm taking him. Now what do you think? Am I going against the force or along the force? What do you think? It's going down, suppose, but still I apply a force against it, no? Check. Okay, do you understand? The object was going down, but I have lifted the object from here to here. See, I have really lifted the object from here to here. It was trying to go down, okay, but I've lifted from here to here. Do you agree with this one? Do you understand this?
Yes.
Okay, so you tell me, am I doing work along the restoring force or against the restoring force?
Against.
Against the restoring force. And don't forget, I've already written earlier, how does your restoring force looks like? It looks like proportional or proportional to negative of y?
Negative of y.
Negative of y. Okay, now at this point you may not be clear because I think I did not make it clear. Okay, one thing I just want to tell you before, so that I want to make it clear to you all, is this. Do you agree that if I change the position from here to here, do you agree that the potential energy changes or not?
Yes, sir.
Yes, sir.
Okay, I'm repeating again. Okay, if I take the object from here to here, the pendulum from here to here, the pendulum was trying to go down. When I change the position from here to here, I've changed the potential energy of the object. You will also agree with me that I am doing work or not?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Do you also agree that if I do lots of work, that means if I bring him not here, okay, let me just remove and bring him here. Now you think and tell me, did I do work or more work?
More.
Yes, I did more work. Do you also agree with me that it has gained potential energy or more potential energy?
More.
Very good, more potential energy. Okay, so very simple idea. So I'm just going to use this logic now. Okay, check. I'm going to write something. F dy. Please tell me what is this? Is it the amount of work done or small amount of work done?
Small amount
Small
of
amount of work.
Amount of work done. Very good. Okay. In producing displacement or very small displacement?
Very
Small
small.
Small displacement. Agreed till now. Okay. Let me write dw equals to what? What is the formula for force, mass into
Acceleration.
acceleration? I'm going to write dy like that. Okay. And dw equals to what is mass? Mass is mass only. Acceleration is how much? How much we got? Anybody remembers? A omega
Omega
square,
square.
but there was a minus sign, if you remember, right?
Yes.
Minus sign, and then I will have sine
Sin omega t.
omega t. Okay. If you don't want to write so many things here, I can just again come back and remove few other things, right? I can remove a and I can remove sine omega t by what? Y. Okay.
Y.
So this is what? This is the formula for. Okay, I have to write dy also, of course. So again, let me just arrange a bit. So dw equals to what? Minus of m omega square
Omega square
y. Okay, and we
y
have
dy.
dy. Is it okay?
Yes,
Is it
sir.
okay, guys? Check.
Yes, sir.
I just want to make one more change here. Okay, I forgot to tell you. I wrote directly. That's why I missed something. What about this and this, guys? The force and the displacement. What do you think? They are same or opposite?
Sir, opposite.
I'll go back. I'll go back and show you the diagram. Say, do you agree with me that the restoring force is acting in this direction or not?
Yes, sir.
Okay, and we are producing displacement in this direction, right?
Yes, sir.
Yes, sir.
So force and displacement are same or opposite?
Opposite.
Opposite.
So automatically, right? I'll write here cos of 180 degree, right? Agree with this, sir?
Cos of 180 degree.
Cos of 180 degree means automatically I'm going to get what sign here? Minus.
Minus.
So I have an extra minus sign and I have minus inside also. The total it will become what, guys? Plus. Okay. Now you must be thinking. Okay, please tell me again. What is this? Who can tell me? What is this again, guys? Same thing. Small amount of work done in displacing the object by very big displacement or small displacement?
Small.
Very
Small
small
displacement.
displacement.
Starting from a position called what? Y. Are you clear? Starting from which position called?
Y.
Called Y. Okay, now we are ready. See, don't forget. Okay, why am I doing all these things? Because I told you just now, if I do work, right, the object or the pendulum will gain what energy?
Potential.
Potential energy, and that is what we are trying to find out. What is the potential energy? We already know kinetic energy. Okay, so what will I do? Check. I'm going to integrate it equals to m omega square. I just can substitute here one more thing. I'll do that. Okay, let me integrate it and I'll tell you what is the meaning of integration now. Okay, check. Say, if I write here 0, what does it mean, guys? I'm starting from which position?
Mean position.
Mean position. Start from
In position.
mean position. Why am I starting from mean position? Because in this position your potential energy will be equal to how much? 0.
0.
Then I'm going to stop somewhere, right? Where do you want to stop? Let's stop in a position where the value of y becomes y. Can you understand? Because I cannot tell you, let it be 1 meter, 1 centimeter. I cannot tell you that. No, let's stop at any value. Can you understand? Now tell me,
Yes.
what is
Yes,
this?
sir.
Now tell me right hand side. What does right hand side represents, guys? Or the whole equation, what does it represent? Work done or total work done?
Total work done.
Total work done.
Total work done, right? In displacing the particle from where to where? From y equals to which position?
0.
0
Till we
to
reach which position? Y equals
Y.
to
y.
Y.
y equals to y, some position called y. Okay, I hope you are clear with this. Everyone clear? Can I say it's clear?
Yes,
Yes.
sir.
Okay.
Yes, sir.
Yes,
So
sir.
tell me, what is the corresponding work done when you just start here?
0.
0.
0.
When you just start, okay, from 0 position, you have done how much work? 0. Why? Because in this position your force is 0. That means potential energy also what? 0. Okay, that means work done also 0. Okay, now check. if we reach a position called what? Y. Tell me, have we done work or we have done lots of work?
Lots of work.
Lots of
Lots of
work.
work.
From 0 to position Y, we have done lots of work. So let's call it what? W.
W.
Okay, so yeah, I'm going to just integrate now. Okay, I'm done talking about all these things. Okay, from 0 to W. So let's integrate. Okay, so what is the integration of this? I told you directly also we can write. Just write what?
W.
W.
W. Okay, here can you identify again who are constants here? M omega,
Mass
M
omega
omega square.
square.
Okay, so I'm going to write here M omega square integration from where to where? Y dy from 0 to y. Okay, so directly also I think you can tell me without the limits. I'll get the answer, no? M omega square. What is the integration of y dy? Answer is
Y
Y square by
y
Y
square
by
by
2.
2. Okay, increase the power, yes, and divide by the increased power. Okay, I think you can follow me on this. We have been doing it. Okay, so this is the formula for your integration. Y, if it's like that, you write like that. If you y square dy, how do you write this one? Y cube. You increase the power and
Cube
divide
by
by the
6.
increased power. Okay, and if integration y to the power 4, those who don't know, just remember what do I
Y
write?
by
Y to the power
Y
5
5 by 5.
by 5.
5.
Yes, okay, those
5
who don't
by
know
5.
integration, okay, this much integration will save you in class 11. Okay, this much for the timing. Okay, so I'm waiting, guys. What do I write now? Y or y square?
Y square
Y
by 2.
square by 2. Okay,
Y
so I'm
square
going to
by 2.
write, yeah, y, oh sorry, work done equals to how much? Half
Half
m omega y square. Is it okay? All of you check. So what is this now? Tell me properly. Work
So total work done.
done. Very
Total
good.
Total
Work
work
done
done.
in displacing
in displacing the object from y equals to 0
y
till
equals to 0
Y
to
is equal to
y.
y.
position
Y.
y. That means the object has reached which position now?
Y.
It is in
Y.
y position. That is the meaning of that, right? Okay. And now you tell me, does it have potential energy or not in this position?
Yes,
Equal
sir.
to how much? Equal to how much?
Yes.
Work.
Half omega square y.
Equal to the amount of work done, because I told you the more the work you do, the more will be stored as the potential energy of the system. So this is the formula for what energy, guys?
Potential
Potential
energy.
energy.
Potential
So
energy.
now we are ready. Okay, now we are ready. We'll add with which energy?
Kinetic energy.
Kinetic
At
energy.
any
energy.
position or at again same position?
Same
At the
position.
same
And then
position.
and then we are going to get what, guys? Okay, let me go back. Where is the kinetic energy? Here it is, the kinetic energy. Okay, I'm going to copy it. Okay, oops, copy and paste it there. Okay, so let me do that quite fast. I am today. Okay, very fast, no Mito, today? Like I drank, what is that? Energy drink, Red Bull. Okay, so now check. So total energy. Okay, total energy. Help me out, guys. What do I write? Kinetic energy, let me write first. Half m omega square. I can write a square minus y square. Okay, plus potential energy is half m omega square y square. Half m omega square y square. Okay, so let's really add. Okay, it's very simple addition. Say half m omega square, let me multiply with a, so I'm going to get what? A square. Let's
A
also
square.
multiply with this one. Okay, what do I get? Minus half
Half
m
m
omega
omega
square
square y
y
square.
square plus half m omega square y square. Do you agree that these two will cancel or not? Check this and this.
Yes, sir.
Yes, sir.
Okay,
Yes,
so
sir.
what is the total energy equal to? Half
Half m
M
omega
Omega
square
square a square.
a square. Now the only thing I want to ask you, look at this. Tell me, does the kinetic energy depends on position or not?
Yes, sir.
Yes,
Yes.
sir.
Different position, we get different type of kinetic energy. Does the potential energy depends on position or not?
Yes, sir.
Yes,
Yes,
sir.
sir.
If the object has different positions, the potential energy also will be different. You can easily tell me at y equal to 0, what is the potential energy from this formula?
0.
0.
Zero.
And at y
0.
equal to plus a or minus a, what kind of potential energy do you get? Potential energy or maximum?
Maximum.
Maximum.
Maximum
You can even
potential
tell me the
energy.
value of maximum potential energy. Tell me what is the maximum value of potential energy. Put y equal to how much? A, right? So I'm going to get half
Half m omega square a square.
a square. This is the maximum value of potential energy. Okay, and do you understand? Look at this. Can I say the total energy is what? Potential energy or maximum value of potential energy?
Maximum value of
Maximum
potential.
And
value
you
of
will also
potential
agree with me.
energy.
Look at the formula for kinetic energy. Do you agree that this one? Okay, Is it kinetic energy or maximum value of kinetic energy? This one.
Maximum value of kinetic
Both are
energy.
same. Maximum value of potential energy is same as what? Maximum value of kinetic energy. Both are same. Not a problem. But do you notice something? Tell me. Total energy depends on position or does not depend on position?
Does not
Does not
depend.
depend.
Total energy does
Does
not
not
depend on
Position.
position. No. Total energy
Position.
even does not depend on time. Check. Please agree with me. Check. Does it depend on time?
No, sir.
No.
No,
So
sir.
what is total energy? Tell me.
It depends upon the amplitude.
It is a constant. Position changes.
Constant.
Position changes with time. Time, of course, changes with time. But total energy does not depend on these two. That means total energy is what? Not going to change.
Constant.
It's a constant. Okay. Okay. So I hope you got till now. Is it okay, all of you? You understood?
Yes,
Yes.
sir.
Okay, I'm done.
Yes, sir.
Okay, I'm just going to stop now.
Yes, sir.
Yeah, okay, I'm going to stop right now. I'm going to send you the notes. So please study this one, and I'm done for today. Okay, thank you, thank you. We'll meet tomorrow. Tomorrow I have to give time to class 12. Okay, so tomorrow I will not take. Okay, can I take Saturday? Saturday is fine. Saturday is what date?
Sure.
Sir, online or offline?
Online, online, online. Offline also I have to call you. No, I think
No, sir.
offline. When did I call you offline? Please remind me. I forgot you. Forgot again.
Saturday only.
I told you Saturday, no? Offline,
Yes,
offline,
sir.
offline. Saturday, what time I told you to come? 11, 10, I don't know. 12, 12, 12. Saturday 12, huh?
Yes, sir.
12 a.m. Okay, please remind me, huh? Remind. I will forget. Okay, if I forget, oh gone, huh? So remind me. Saturday 12. Remind me tomorrow also. Yeah, and online again back. No, I will take Saturday again. Saturday at what time? 8. 8. Saturday at 8 or we change?
Sir, 12 p.m.
12 p.m. p.m. Yes, yes, very good. Okay, okay. I'll stop. I'll stop recording. I'll stop. Okay. So I think this is fine.